Right. So we need to make P the subject of the formula, right? Now with transposition, guys, transposition means you move a term from one side of the equation to the other side of the equation, or you do the opposite of the operation on the other side of the equation, right? So let's just, before we even do this question, let's just recall a few things, right? The opposite of addition, well, addition will change to subtraction, and vice versa. Subtraction will change to addition. What about division? What would that change to?
Multiplication.
Multiplication.
Correct. Multiplication, and multiplication would change to division. And what about squaring something? Like if you have x squared, what's the opposite of squaring something?
Miss,
Reynolds?
make the square root.
The square root, right? So the opposite of squaring something is taking the square root of it. So the opposite of taking x squared will be taking the square root of x. So taking the square root of x squared will actually give you x, right? And likewise, to get rid of square roots, you would square, right? So that's the opposite of squaring. And similarly with any rooter, by the way, so like if you had the cube root, for instance, then the opposite of that, sorry, if you cube something, then the opposite of cubing will be the cube root. And if you had something raised to the power of 4, the opposite of that will be the fourth root, and so on. But you don't really see questions with the fourth root. You will more see cube root and square root, but not the fourth root, right? So this is a list of all the possible operations that you will see in your questions for CSEC, right? You will see, you'll have to undo addition, subtraction, division, multiplication, squared, and cubed, right? So the first thing here that we need to get rid of, well, P is all the way here. This formula is telling us that R is equal to the square root of the sum of 4 plus, well, the 4 and 3p squared all divided by s. So guys, you have to do it piece by piece, right? So the first thing I'm going to get rid of is the square root. So look on the side here and tell me, what do I do to get rid of a square root? Based on this that we just went through here. What do you do to get rid of a square root? Anybody? Isabel, do you know? What is the opposite of taking the square root?
Miss, you would square it.
To square it. That's this one, right? So the opposite of, well, more like this one here. The opposite of taking the square root is to square something. So if I want to remove the square root, I'll square both sides. So this will end up being r squared is equal to 4 plus 3p squared, all divided by 3, right? So when you square a square root, you get rid of it. So I've squared it, and now I have r squared, and you have to do the same thing on both sides. So this will be r squared is equal to 4 plus 3p squared. Now here, this means I want to get rid of the 3, right? Here, this is, I'm dividing by 3. So how would I get rid of dividing by 3? What would I have to do to get rid of dividing by 3? What's the opposite?
Multiply.
Multiply. So then I'll multiply by 3. So on this side, I'll have 3r squared. And when you multiply by 3 on this side, well, you'll get rid of it, right? Or in other words, I transpose 3 to the other side, so I do the opposite of the operation. So instead of divide by 3, well, I'll have to multiply by 3. So now I have 4 plus 3p squared is equal to 3r squared. Now, so you see I'm getting closer and closer to the p, right? Because p is what I need to make the subject. So here I have plus 4. How to get rid of plus 4?
You have to subtract it.
Have to
Miss,
subtract it.
wouldn't it be SR squared?
Oh, that's S. So where did I get P from? Oh my gosh. I mean, how did this change to? Oh Lord. Sorry. I don't know where I got that 3 from. Thank you. It is S. Sorry. It's S. So here would be S R squared. Yeah. Instead of 3. Sorry, I don't know where I got S 3 from. Made a mistake. Right, so now you have SR squared and well, I'm adding 4 here, so to get rid of that, I would have to subtract it on the other side, or to move it to the other side, I'll have to minus it. So this will be SR squared minus 4 is equal to 3P squared. Guys, 3P squared literally means squared multiplied by 3. So I'm multiplying by 3 here. So to get rid of it, what would I have to do? Move 3 from this side to the other side. What's the opposite of multiplication? Guys,
Division.
opposite of multiplication is division. So I'll have to divide by 3. So it'll be SR squared minus 4 all divided by 3. And that is equal to P squared. And finally, I have P squared. I need to make P the subject. So to get rid of square, what's the opposite of squaring?
Square root.
Square root. So I'm going to have to take the square root. So this will be SR squared minus 4 divided by 3 is equal to P. And there you have P as the subject of the formula. P is equal to the square root of SR squared minus 4 over 3. That's your answer. So to go over again what we did, you had R is equal to the square root of 4 plus 3P squared all divided by S. The first thing you need to do, you need to get rid of that square root because P is inside of that whole square root thing. So to undo the square root, or if you want to think of it as moving the square root symbol from one side to the other side, you'd have to do the opposite of it, which is the opposite of square root is the square. So that's how come this side became R squared. What you'll be left with on the right hand side will be 4 plus 3P squared divided by S. So you're gonna be left with what's inside of the square root. Next, here was divided by S. So to get rid of division or to move S from the right-hand side to the left-hand side, we would multiply because it's being divided on the right-hand side. So when you move division, a term that is being divided from the right-hand side to the left-hand side, it will become multiplication, since multiplication is the opposite of division. So when I move S to the other side, I will have SR squared is equal to 4 plus 3P squared. Now, here, this is 3P squared plus 4. So to get rid of addition, a term that is added, when you move it to the other side, you would have to minus. So this will become SR squared minus 4 is equal to 3P squared. Now you're left with SR squared minus 4 divided by 3 is equal to P squared, and the opposite of squaring is taking the square root. So you'll have the square root of SR squared minus 4 all over 3 is equal to P. So you just have to think about it in terms of doing the opposite, guys. Doing the opposite and of doing it piece by piece by piece, right? The last thing that you would end up with is the operation that is next to the term that you're trying to make the subject. Meaning that in this formula, I have lots of operations happening. I have the square root, I have division, I have addition, I have multiplication, and I have squaring. So you have to undo it in that exact order. So basically backwards though, because first to get to 4 plus 3p squared divided by s, you would first have p, and then you would square p, and then you'll multiply p by 3, then you add 4 to that, then you divide by s, and then you take the square roots of all of that. So to undo it, to get back to p, you have to do each of those steps in that order, right? So you would first, what do I mean? So let's write over the formula again. So I want you all to think about it intuitively like that, right? So the formula was R is the root of 4 plus 3p squared divided by s. That was the formula, right? So in order to get this formula, how they would have built this formula, you would have started with p. So the first step would have been you would have had p, right? And then the second thing you do, you'll multiply p by itself to get p squared. Then you would have multiplied p squared by 3 to get 3p squared. After that, you would have added 4 to it to get, well, 4 plus 3p squared is the same as 3 plus 3p squared plus 4. So you added 4 to it, right? So I'll write it like this instead, just because that's exactly how it is written in the formula, right? And after that, the fifth step would have been dividing that whole 4 plus 3p squared, whatever you got there, by s. And that's the final step would have been taking the square roots of that whole thing. 4 plus 3p squared divided by s. So to undo it now, to make p the subject, so to get back, so now you're starting from here. This is your starting point, right? And I want to get back to p. So the first thing I'll have to undo is I'll have to do the opposite of the squaring, the root, sorry. Then do the opposite of division, then the opposite of addition, then the opposite of multiplying by 3, then the opposite of squaring, and then I'll get back to p. So that is how you have to think about it as well. You have to start with the term, right? Think about how you would have gotten to the point R, right? So to undo it, to get back to P, you have to go back in this exact order, well, backwards. So you have to go from 6, you'll do 6 first, then 5, then 4, 3, 2, 1. So the first thing is to take the opposite of square root, which would have been squaring R, right? And then it will be the opposite of dividing by s, which would be multiplying by s. And then it would be the opposite of adding 4, which would be subtracting 4. And the opposite of multiplying by 3, so that would be dividing by 3. And then the opposite of squaring, which is taking the root of that, which would have given you SR squared minus 4 divided by 3, and then you're going to end back up with P, right? So let's look at the other question, and we're going to think about how they reached to that point, and then we're gonna undo it, right, by transposition. So the next question is A. This question A, this is from June 1983. So they want us to make R the subject, you have the area is equal to pi multiplied by R minus the radius all over 2 all to b squared. Right, and we need to make a capital R the subject. Well, in this one, the first thing you'd have done to R, right, is you would have had R, and then the next thing you did is you subtracted small r from that, and then you divided that, the difference of R and R, by 2, and then you squared it, and then finally you multiplied all of that by pi, right? So these are the steps. So to undo it now, we have to start with this last step, which is this last step was multiplying by pi. So what is the opposite? If I multiply by pi, guys, to transpose it to the other side, what would be the opposite of multiplying by pi?
Divided by pi.
Dividing by pi. So on this side, I'll end up with a divided by pi. So I've undone this step here. Next, I have squared. So what's the opposite of squaring?
Square
What is the opposite? Square root, right? So then I will have to take the square root, right? So the square root of a divided by pi. So I've gotten rid of that square root now. So I'll end up with r minus r over 2. So now I've undone this step. And then this third step here was dividing by 2. So what's the opposite of dividing by 2? Ladies, opposite of dividing by 2. Opposite of division is
What's the equation multiplied by 2? Miss, I'm sorry,
multiply.
I left because I don't know what's been going on with my internet, but it's so annoying. It doesn't like, I don't know. When I like if I go somewhere, like I said, in place of my house, it will not work good, and it's very annoying. I'm very sorry.
But that's okay. So that'll be 2 times a by the square root of a divided by pi. You don't need to write the brackets. You could just leave it like this, right? And then, so now I have undone this step, right? So now all I'm left with here is r, take away r. And then this step was subtracting small r. So how would I get rid of subtracting small r? Or what would I do to move minus r to the other side of the equation, girls?
You add it.
I'll add it. So now I'll end up with 2 times the square root of a divided by pi plus r would give me capital R. And there I have the subject of the formula. R is equal to 2 by the root of a divided by pi plus r. All right, that's another one. And then I'm going to give you all one to try for me. Right? But think about it. Think about what is happening in the formula. You have to think about all the operations that are going on in the formula in order to undo it, right? Because in order to transpose a term from one side of the equation to the other side, you have to know the opposites of the operation. And in order to know what the opposites of the operation is, well, you'll have to know what the operation is to begin with. All right, let's see. This one, we have given that is equal to a square root of 1 minus n squared divided by n, express n. We need to make n the subject of the formula. So express n in terms of m. This one is a little trickier than usual. But anyway, let's see. So we got to start with, we need to have n is equal to something, right? So if you look at the formula here, the first thing there, well, actually, this is the square root of 1 minus n squared divided by n. So the first thing we need to get rid of is this division by n. So if I were to, let me write this over, m is equal to the root of 1 minus n squared divided by n. So first thing I'm going to get rid of is this division by n. So to get rid of division by n, you would have to multiply it. So to move n from the right-hand side to the left-hand side, you'll have to multiply by n. So you'll end up with n times m, which is nm, and that would be equal to the root of 1 take away n squared, right? Now I have square roots. So to move square root to the other side or to get rid of square roots, I square both sides. So this will end up being n squared. This is equal to the 1 minus n squared. Right? Now nm squared is equal to you're squaring both terms n and m, right? So nm squared would actually be n squared m squared, right? Because I'm just doing this on the side, right? nm all to be squared is equal to n times m, which would be equal to n squared m squared. So I want to write it like that first of all. So n squared m squared is equal to 1 take away n squared, right? Now I want to move this 1 to the other side. Now here, right, this is positive 1, right? This is not negative 1. 1 minus n squared is the same as saying minus n squared plus 1. So if I move plus 1 to the other side, it will be minus 1. But actually, what we should do at this point is get all the n's to one side of the equation. So you see how you have n squared here and n squared here? You want to get all the terms with n to the same side of the equation. So I'm going to keep n squared m squared over here. So this will be n squared m squared, and this is minus n squared. So when I move minus n squared to this side of the equation, it will be plus n squared. It's equal to 1. Now, remember the question is telling us to make n the subject of the formula, right? So to get n by itself in this expression, I would have to factorize n out of the expression. So between n squared m squared plus n squared is the common factor here. So if I were to factorize, I'll have n squared into this would just leave me with m squared, and then n squared into n squared is 1. So this gives me n squared times m squared plus 1 is equal to 1. Remember, I want n by itself, right? So the next thing that I'll do is I'll move that whole bracket, m squared plus 1, to the other side of the equation. Now, here, when you factorization actually means this term on the outside here, n squared, multiply by what is inside of the brackets. And to confirm that, well, n squared times m squared is n squared m squared, and n squared times 1 is n squared, and that's the same thing as this, right? So that's just to show you that that's what factorization means. It's actually multiplication. And if you are moving multiplication to the other side of the equation, you'll have to divide. So you'll end up with n squared is equal to 1 divided by m squared plus 1. The question is not asking us to make n squared the subject, it is asking us to make n the subject. So at this point, I want to get n by itself. So to get rid of the square, you'll have to take the square root. So n would be equal to the root of 1 divided by m squared plus 1. Now this is this is like one of the trickier ones than before, because unlike all the others that we did so far, and even from like in our previous classes, there's only like one term in P. For instance, here we needed to make P the subject, and there was only one term in P, right? So you didn't have to like factorize anything. But, and even in the second example, you did have two R's, but one was capital and one was common, and we had to make capital R the subject. So it was fine. But in this one, we actually have two terms in n. You have n here and n squared. So whenever you have a question that has two terms, it's going to bring you down to a point where you have to factorize, right? So keep this, make sure you write down the solution, right? So, and I'm going to go through it again. You have m is equal to the root of 1 minus n squared divided by n. So the first thing, you want to get rid of this n. So this is divided by n. So when I move division, the n from the right-hand side to the left-hand side, I'll have to do the opposite of the operation. So I'll now have n times m, or m times n, right? Which will just leave me with the root of 1 minus n squared on the right-hand side. The next step, well, I wanted to express I want to get rid of the square root, right? Because I still have n underneath that, inside of that square root. So I need to get rid of that square root to access n. So to get rid of the square root, you have to square the other side. Well, actually, you're squaring both sides of the equations, right? So you'll end up with nm squared. But you have to be careful that nm all to be squared is not the same as nm squared. Nm squared literally means n times m, which is nm squared. But nm all to be squared would be n squared times m squared, right? So it's important. I think that is an important thing to note. So like if you have it in your book, make sure you put a little asterisk there, right? Because that is a part that I think students may make a mistake at. So right, so nm all to be squared will be n squared m squared, which is equal to 1 minus n squared. At this point, you want to make you want to group all your n terms because the objective is to make n the subject. So what I did is I kept n squared m squared on this side, and I moved n squared from the right-hand side to the left-hand side. So this is minus n squared. When I move it to the left-hand side, I will have to add. So it will be n squared m squared plus n squared is equal to 1. And now I have two terms in n. So whenever you have two terms, you can two terms with a common factor, you can factorize. So factorizing this side of the equation, I can use n squared as the common factor since n squared is common to both this term and the second term. So I end up with n squared into this first term would leave me with m squared, and then n squared into n squared is 1. So I end up with n squared multiply by the sum of m squared plus 1 is equal to 1. So to get rid of these brackets, I'll move it to the other side of the equation. And since it's multiplication on the left-hand side, when I move it to the right-hand side, it will become division. So I'll have 1 divided by m squared plus 1. And therefore, the final answer, since n squared is equal to 1 divided by m squared plus 1, n would be equal to the square root of 1 divided by m squared plus 1. Right, let's do another one. I haven't seen a question like that one in a very long time, actually. Not in the last few years. These questions here from these older past papers, they were much more difficult than the newer ones. So this one is from 1986. It says if 1 over R is equal to 1 over V plus 2 over T, express T should be in terms of R and V. So in other words, make T the subject of the formula. Right? So you have 1 divided by R is equal to 1 over V plus 2 over T. So the first thing I want to get rid of is this plus 1 over V. So to get rid of plus, when I move 1 over v to the other side, I would have to subtract it since I'm adding it on the right-hand side. So 1 over r minus 1 over v is equal to 2 over t. Pay attention to this part, girls. So here, I will first simplify this left-hand side. Now, when you're working with fractions, I wanted to do a little fractions with you all today. When you're working with fractions, if you have to simplify an expression, an algebraic expression, where you have two different terms in the denominator, you have to get a common denominator. The common denominator here will be r times v. So here you're going to have rv, right? And then just like with regular fractions, you'll say r could go into rv, v times, so then the numerator will be 1 times v, so this will give you v. And then you'll say v could go into rv, r times, so you multiply 1 by r to get r. And that is how you would simplify an algebraic fraction. All of this is equal to 2 over t, right? So just to bring that home, if I had 1/3 plus 1/2, right? Well, you know that, sorry, that's minus. So we'll do 1/2 minus 1/3 instead. So 1/2 minus 1/3. Now you know that with fractions, you cannot add or subtract with different denominators. It's the same thing with algebraic fractions. You cannot add or subtract if you have different denominators. So you find your common denominator with regular subtraction. So you say 2 times 3 is 6. So the common denominator here is 6. And then you'll say 2 could go into 6 3 times. So 1 times 3 is 3. And you'll say 3 could go into 6 2 times. And 1 times 2 is 2. It's exactly this that I did here, except I had r and v. So the common denominator would have been r times v, which is rv. R could go into v times. So 1 times v is v. V could go into r times. So 1 times r is r. And now you end up with two fractions on either side of the equation. To get rid of two fractions on either side of the equation, or to get rid of fractions, what you do is you cross multiply, right? So you multiply this term by this numerator by this denominator. So you'll end up with t multiplied by v minus r is equal to denominator rv times 2. So that'll be 2rv. And now that I have t multiplied by v minus r, well, I have t by itself. This is multiplied. So to move v minus r to the other side, I would divide by it. So it'll be 2rv divided by v minus r. And here you have t as the subject of the formula. We're going to do one more, and then we're going to take a short break, girls.
Excuse me, miss.
Yes.
Could you go over that one, please? My internet was breaking up.
Yeah, no probs. From the start, we do it from the start.
From where you get the second line?
Okay, cool. So we 1 over, I'll do it from the start. 1 over r is equal to 1 over v plus 2 over t. So the first, I need to make t the subject. So I'm going to move all the other terms to the other side of the equation first. Because this is plus 1 over v, sorry. When I move it to the other side, it will become minus 1 over v. So I will now have 1 over r take away 1 over v is equal to 2 over t. Right? Now, to simplify this side of the equation, 1 over r minus 1 over v, I would use the rules of adding fractions, adding and subtracting fractions. When you are subtracting fractions that have different denominators, you have to find the same denominator or common denominator. So the common denominator here, you multiply the two terms. So I'll say r times v. So the common denominator will become rv. And then, just like with regular fractions, I'll say R could go into RV, V times, and I multiply the old numerator by that. So 1 times V is V, and then V could go into RV, R times, and 1 times R is R. So I end up with V minus R over RV is equal to 2 over T. Now, whenever you have fractions on both sides of the equation, to get rid of the fractions and to just be able to work with the whole numbers again, you cross multiply. So you multiply the numerator on one side by the denominator on the other side. So on this side, I'll have T times V minus R is equal to 2 times RV. So I end up with T by the difference of V and R, so T times open brackets V minus R, close brackets, equals 2 times RV, which is 2RV. And now that I have T multiplied by V minus R, I could make T the subject by simply moving V minus R to the other side. And because it was multiplication on this side, when I move it to this side, it will be division. Right, Jen?
Okay, thank you.
You're welcome. All right, the next one is 4 over x plus 3 over y is equal to 7 over t. And we need to make t the subject. So this one is very much like this, almost the same actually. Right? So make t the subject. Question literally says express t in terms of x and y. That means to make t the subject, right? So unlike this last one, right, where I had to like move 1 over v to the other side, I already have 7 over t by itself on this side. So the first thing I'm going to do, because it's fractions on both sides, I want to simplify the left-hand side, all right? Now, these are different denominators, and you cannot add with different denominators. So the common denominator here will be x times y, which is xy. You say x could go into xy, y times, so you multiply 4 times y to give you 4y. And then you say y could go into xy, x times. So you multiply 3 by x, which will give you 3x. And all of that is equal to 7 over t. Once you have fractions on both sides of an equation, to get rid of it, you cross multiply. So I'll multiply t times 4 plus 3x. So that would be t times 4y, plus 3x. And then that is equal to 7 times xy. So this would be 7xy, right? And now to just get t by itself, I'll move 4y plus 3x to the other side, so I'll divide by it. So 7xy divided by 4y plus 3x. And that is your answer. T is the subject. Let's take a short break, girls. Okay. So here, x is equal to y minus 2 divided by y minus 3. So I'm going to move that whole denominator to the other side. This means divided by y minus 3. So when I move it to the left-hand side, I will multiply by it. X times y minus 3 is equal to y minus 2. All right. Now, I want all my y's on one side of the equation. But before I do that, because I need to get this y from inside of these brackets, right? So to get the y outside, I would have to I'll have to distribute x, right? Meaning I'll have to multiply x by what's inside of the bracket. So x times y will give me xy. And x times negative 3 is minus 3x. All of that is equal to y minus 2. At this point, I want to group all my y's together and all the other terms on the other side of the equation. So I'm going to move y from the right-hand side to the left-hand side. Now this is positive y, right? Or I could represent this right-hand side as negative 2 plus y. So I'm moving plus y to the left-hand side. So it will become minus y is equal to minus 2 plus 3x. When I move minus 3x to the other side, it'll become plus 3x. Now I have these two terms that have y in them. So to get y by itself, I'll factorize. So y into xy is x, and y into minus y is minus 1. And this is equal to, I'm going to rewrite this side of the equation just to put the positive term in front. So this will be 3x minus 2. All right. And now I have y times x minus 1. So to remove that x minus 1 to the other side, I would divide by it. So I'll end up with 3x minus 2 divided by x minus 1. I want you all to make a note of this one especially because this one is a very common for like functions. I don't know if you girls did functions as yet, but we will do functions soon. And when you have to find the inverse of a function, this is how it's done. A specific function, um, this is a popular type of question that you get with functions, and this is how it's done, right? You have to change the subject to the formula. Um, so I want you all to make a note of this one in particular. These types that have the variable in both, like more than one place, like it has two terms in the variable that you're trying to make the subject of the formula. This is the one that is the most troublesome. So out of the examples that we did so far, this one and that's, I think it was the third one, these are troublesome ones. So pay attention to it when you're studying, and even when you're like watching these videos, if you're watching this video over. Right, okay, girls, I want you all to try one for me. Try for me. Given that C is equal to 2 pi r, and that's actually the area, sorry, the circumference of a circle. And V is equal to 1/3 times pi r squared, which is the volume of a sphere, I believe. For the first one, express E in terms. Oh wait, no, I'll do this one with you because I didn't give you all any like this as yet. Express V in terms of C pi to each. This one's a little tricky as well. Right, so you need to express V in terms of C pi each. Okay, so if C is equal to 2 pi r and V is equal to 1/3 times pi r squared, express V in terms of C, pi, and h. All right, so this one is unlike any that we did before. We have two separate formulas, and we need to express, we need to use both of them to make V the subject. So let's see, what can we do here? I have to think about this one. So C is equal to 2 pi r, and V is equal to pi r squared. All right, so what we need to do here, guys, is we need to look at the fact that both equations, so C is equal to 2 pi r and V is equal to 1/3 pi r squared. Notice that both of them have an r in them. right? So both of them have pi and r in them. But more specifically, because this one actually, this is, oops, this one is pi r and this one is pi r squared. So really, both of them, we can say they both have pi, right? So if from using this one, right? If we use using C is equal to 2 pi r, I could make pi the subject of the formula in this one, and C is equal to 2 pi r. So to make pi the subject, well, this literally means C is equal to, this means C is equal to 2 times R times pi. And as you know, multiplication is commutative, so it doesn't matter the order, right? So 2 pi R is the same as saying 2R times pi. So to make pi the subject here, I could divide by 2R. So pi is equal to C over 2R. Pi is equal to C over 2R, right? And now that I have this pi is equal to C over 2R, I can substitute that into the equation for V. So I'm going to substitute is equal to, I'm going to write it in a different color so you could see it. Pi is equal to C over 2R into formula for V. Right? So into V is equal to 1/3 pi r squared. And that means, just like with substitution, wherever I have pi in the formula, V is equal to 1/3 pi r squared, I'm going to replace pi with C over 2R. So this formula would now be V is equal to 1/3, well, it's times pi, right? So that would be, and I'm replacing pi with C over 2R. So 1/3 times C over 2R by R squared. And now if I were to simplify this, now this one is tricky, guys, and I'm telling you, I'm doing it because it's on the worksheet, but this kind of question is very uncommon in CXC now, right? These are hard questions. It's good to understand the algebra behind it. So this will be V is equal to, well, 1/3. You have to simplify your answer, so you can't leave it like this. 2 over C over 2R times R squared would literally mean C over 2R times R squared over 1. Right? So what can happen here is I can reduce. I can say R into R squared is just R, and R into R is 1. So I'll end up with 1 times C times R on top, all over 3 times 1 below, which will give me 1 times C times R is CR over um for 3. Wait a minute, where did they get C? Did I make a mistake with the question? Oh, it was supposed to be C pi and R. Okay, this part does not make any sense. Should have been express V in terms of C and R. All of these questions have errors, girls. Because there's no H here. It doesn't make sense to have H there. All right, I want you all to try one for me. Try for me. Um, L is equal to, if L is equal to the square root of 3m over 5, make m the subject. Try this one, girls. Remember that you have to undo each operation, right? Bit by bit. So if you're making m the subject, think about this as the square root of 3 times m divided by 5. So the first thing you're undoing, square root, then division, then multiplication. Anyway, try it for me. Send me a picture when you're done. I'm waiting. If you're very confused, don't worry. I'm going to go through it afterwards. Right, so this was, I forgot this 2 here. So this was 3 times 2 times 1, because this is 2 here. So this would have been CR over 3 times 2, which is 6. I made that mistake. I'm so sorry. Correct it if you wrote it down, please. Right. For this one, then the mistake that you made, Genesis, is that you wrote it as L is equal to the square root of 3m over 5, right? But the question is really L is equal to the square root of 3m divided by 5, right? So the square root of this entire thing inside here. So the first thing that you would have to do is you'll have to undo the square root, which means you'll have to square. So this will end up being L squared is equal to 3m divided by 5. And then to move the 5 to the other side, you would have to multiply by it since you're dividing by it on this side. So this will become 5L squared is equal to 3m. And since 5L squared is equal to 3 times m, well, m, you'd have to divide by 3. So it would be 5L squared divided by 3 is equal to m. Right, Jan? But the way you wrote it with the solution that you had is actually correct. However, this is the question. The question is the square root of 3m divided by 5. So 3m divided by 5, all of that, the square root of that. So the first thing would have been to remove the square root symbol. To remove the square root, you have to square both sides. So you'll end up with L squared is equal to 3m divided by 5. And then the next thing is you divide it by 5 on the right-hand side. So to move that to the other side, you'll have to multiply by it. So you'll end up with 5L squared is equal to 3m. And then, well, this literally means m times 3. So to move 3 to the other side, you would have to divide by it. Right, Jan?
Yes, miss.
Okay. But your answer, right, for the question that you wrote down is correct, huh? This is the correct question here. Because the square root of 3m all divided by 5 is not the same as the square root of 3m over 5, right? So let's make a note of that. Right. Okay, girls, try another one then. Try for me. Didn't get some of your work? Is it that you all weren't sure what to do? Or you just didn't finish as yet? Let me know. Message me and let me know.
I was already not sure, but I'm good now.
Okay, cool. Try for me. Uh, 2x over. Actually, I'm gonna put it back on the page that we did one like this first before you do it. So this is the example of the one that I'm gonna give you now, right? So you're trying, I'm just leaving it on this page so you could see it. Putting it in this box here. So you're trying make x the subject, you're trying this one. And the hint is to express the left-hand side as one single fraction first. Try this one, girls. Send me a message if you're really not sure where to start, okay? It is kind of tricky. Let's do it together. So I'm glad to see that you kind of get through the first part. So the first thing is, okay, I'm gonna just put it on the next page, right? Give me a second. So it's 2x over, where did it go? Hold on, I lost it. 2x over 3 plus 4 over y is equal to 1. So everybody got through the first step, which was to make this left-hand side one fraction. So the common denominator here will be 3y, 3 times y, which is 3y. And then you say 3 could go into 3y, y times. So then you multiply 2x by y, which will give you 2xy. And then y could go into 3y 3 times. So 4 times 3 is 12. All of that is equal to 1. So to make this one fraction, I'll move 3y to the other side by multiplying. So you'll end up with 2xy plus 12 is equal to 3y times 1. So that'll be is equal to 3y. All right. So then 2xy is equal to 3y take away 12. And therefore x would be equal to 3y minus 12 divided by 2y. This is the answer, girls. Remember that 2xy literally means x times 2y. So if you want to get x by itself, you could just divide by 2y. So that's why I moved 2y to the other side by dividing by it. That was 9. Let's do another one. Let's say we have b is equal to 3a plus 2 divided by a plus 3. And we need to make a the subject. Right? So remember, I told you all, whenever you see one looking like this, you're going to end up with some kind of factorization where I have to make a the subject and it's in both the numerator and the denominator. I'm going to end up with some sort of factorization. So the first thing I'm going to do is I'm going to move a plus 3 to the other side of the equation because I'm dividing by it on the right-hand side. So to move it to the left-hand side, I'll have to multiply. Notice I'm moving the entire denominator. So b by a plus 3 is equal to 3a plus 2. Then I remove these brackets so that I could get A outside of the brackets. So B times A is AB or BA, and B times 3 is 3B. That's equal to 3A plus 2. Now I group all my like terms to one side. So I'll group all my terms with A. I'll keep AB on this side. This is plus 3 on the left, on the right hand side. So move it to the left hand side. It becomes minus 3A is equal to 2. Moving 3B to the other side. So it become minus 3B. Now I have two terms with A, so I factorize. I'm gonna factorize A out of those terms. So that'll be A into B minus 3 is equal to 2 take away 3B. And therefore A is equal to 2 take away 3B, all divided by B minus 3. Here I have made I have made A the subject of the formula. Try this one, please. Try for me. Oh, wait, I think I just gave you all this. No, no, I didn't. Right? This is the square root of 5m divided by 12n. Make um make m the subject of the formula in this one. Right? And then do this one. This one is a substitution one. You have to substitute the values into the formula. There you go. Try these. Going to be right back. 7 was t is equal to the square root of 5m divided by 12n, and we had to make m the subject. So the first thing you do, you get rid of the square root. To get rid of the square root, you square both sides, so you'll end up with just t squared is equal to 5m divided by 12n. Now I want to move 12n to the other side. Well, this is divided by 12n, so when I move it to the other side, I will multiply by it. So 12n p squared is equal to 5m. Then this literally means m times 5. So to get rid, well, to move the 5 to the other side, I'll have to divide by it. So I'll end up with 12nt squared divided by 5 is equal to m. So here you have m as the subject, where m is equal to 12nt squared divided by 5. Then number 12, it says if A is 4, so A is equal to 4, B is equal to -2, and C is equal to 3. Calculate the value of A times B minus C, all divided by B by C. So all you have to do here, girls, is you substitute each term, the value of each term into the formula. So wherever I have A, I'll replace it with 4. So that'll be 4 times B, which is -2. So 4 times -2, take away C, which is 3, right? And all of that is to be divided by B again, which is -2 times C, which is 3. Right? Brackets mean multiplication. So now I work it out. Remember BODMAS, so you work out what's in the brackets first. So this will be 4 times, well, -2 take away 3 is -5 divided by -2 times 3, which is -6. So this will give me, now I could cancel here. I could say 2 into 4 is 2. And 2 into -6 is -3. This would leave me with 2 times -5, which is -10 over -3. And the negative divided by a negative is a positive, so this will be 10 over 3. That's your answer. You could have, however, said 4 times -5 divided by -6. 4 times -5 is -20 divided by -6, which will be, well, negative by negative divided by negative is a positive, and then you reduce this fraction. 2 into 20 is 10, and 2 into 6 is 3. So you get the same answer. And lastly, the last one, given that R is equal to 2p squared divided by q minus 3. And I want to make q the subject. Okay. So that one would have been to make p the subject. Let's see. First, I want to get rid, I'm going to need q to come out of this denominator. So I'll cross multiply. So I'll get r times q minus 3 is equal to 2p squared. That's how you get rid of the fractions. Anytime you have fractions on both sides, or even if you just had r, you could put it over 1 and cross multiply. I don't know if you all remember that from when we were doing trig. So r times q minus 3 and then 1 times 2p squared. So r times q, now you remove the brackets so that we get q on the outside here of these brackets. So r times q is qr, and r times minus 3 is minus 3r is equal to 2p squared. So then q r is equal to 2p squared plus 3r. And finally, q would be equal to 2p squared plus 3r divided by r. And that's your answer.